last chapter was mainly what's the derivative and some basic things with the derivative, like but obviously Isaac Newton didn't spend all that time coming up with derivatives just for the fun of it. There was a reason. Derivatives are very useful. So for the next 2 chapters, we're going to be kind of looking into what derivatives can do for us. This chapter, we're going to focus mainly on curve sketching and how it can help us find things like maxes and mins and what a curve looks like based on the derivative. Next chapter, we will spend time on applications of derivatives, velocity, position, acceleration. Those of you in physics will love that chapter. It's some things that relate to the physicsy side of why Isaac Newton thought a derivative was so important. That will be chapter 4. So this chapter will kind of look at graphically what a derivative can tell us. So the first thing, this is just kind of walking you through some pre-cal words to remind you of some things. What does the word extrema mean? A maximum or a minimum value, an extreme value on a graph. So that's what the word extrema means. What is the difference between a local maximum and a global maximum?
Local is relative to the graph around it.
Around a certain area, good.
And global, which is overall.
The whole graph, perfect. If you had me for Algebra 2, you might remember me talking about Bill Gates at the time, which through the richest person, I think the richest person in the world now is somebody in Mexico. I think that is a tech company, I'm not sure. But anyway, so let's pretend it's Bill Gates because I don't know who else it would be. So he's the richest man in the world. He is a global maximum. He is also a local maximum in his town, right? He's the richest person in his town too. But then we have our richest person in Greenwood. I don't know who it is, but we have one. Locally, they are a maximum. They have the most money in Greenwood. But they're not a global maximum. They're not the richest person in the world. So that's kind of the difference in a local maximum and a global maximum. Global maximums are local maximums because, of course, they are locally. They're the richest person. They just also happen to be globally. Global maximum and minimum of this graph. Well, what is the global maximum? 2,4, the point 2,4. So the maximum is the value of 4. That's the maximum. It occurs at 2. And I want to talk a little bit why I use that wording. If I throw this pin up and I ask what's the maximum, what do you tell me? How high it went, right? I don't really care how far it went. That wasn't the question. So the maximum is the height. The x value is just square. And the minimum would be 0. This notation will kind of save you a lot of mistakes on maximums and minimums because I kind of covered all my bases. They asked me what the maximum is, I told them. They asked me where the maximum happened at, I told them. So I answered both questions in one. When is f prime positive, negative, or 0 on this graph? Well, when is f prime positive, and what even would you be looking at? Good. Positive slope would be f prime positive, negative slope would be f prime being negative, and a topping out point would be a 0. So f prime is positive from 0 to 2. And you may remember from pre-cal, you always list x values when you're telling me where on the graph because y values can repeat, so they don't tell you bigger. So I'm always going to list x values. F prime would be negative on 2 to 5 and 0 at x equals 2. Any questions about that?
Why is it 0 at x equals 2?
That tangent line, if I were to draw a tangent line, it would be horizontal there. When is the graph increasing or decreasing? I just answered that question, didn't I? It's increasing when f prime is, oh, that's interesting, right? going to be important. Increasing from 0 to 2, decreasing from 2 to 5. This is just a picture to say what we already said about absolute and global things. These are local minimum values. This is a local minimum. This is a local minimum. But it's also an absolute minimum. So absolute and global mean the same thing. Local and relative mean the same thing. So these are those two words. So absolute min, absolute max. But then every peak and valley is a local min or max. That is the exact same picture. The new word for today is called a critical point. A critical point is a potential maximum or minimum. And what you notice is that at all of the potential maximums and minimums, the derivative is either 0 or undefined. Would you agree if you look at all those maximums and minimums, the derivative is either 0 or undefined? The slope is either a horizontal tangent or a sharp corner. So, all of those places where the derivative is 0 are potential maxes or mins. So, extrema can only happen at critical points or at end points, the ends of the graph. And so you can tell there's an obvious connection between the derivative and the extrema.
The C1, how would you like, is it like stuck there for a second? Like,
Yeah, it's got a little stall in it.
so like, how would you put that in here?
Now, it's not actually a max or min.
Yeah, but if you were doing the, where f prime equals 0,
You would get that as a critical value because the derivative is 0 there. Turns out it's not a max or min, so we'll have to figure out how to decide if it's a max or min. But as far as right now, all we know is that it's a critical point, but it just happens to not be a max or min. So we're about to find out how to tell which one it is, or if maybe it's not here. So let's look at that. What happens at the maximums? It switches from increasing to decreasing, or f prime switches from positive to negative. We're going to agree. What happens at the mins? What happens at the one that ended up being neither?
it goes from increasing to increasing.
And so it doesn't ever make that switch, right? So you just did something out there, definitely. Critical points happen when the first derivative is 0 or does not exist. They can be maximums, they can be minimums, or they could be either one. Ones that we thought might be a max or min, but were just a stall out point. So if I'm doing a distance time graph and I'm walking and I stop, I could turn around and that would give me a maximum, or I could bend down time actually would keep going, and that wouldn't be a maximum at all. It would just be a place I stalled for a second. So we've got options like that. The local minimum happens when the derivative is either 0 or undefined, and the derivative changes from positive to negative, increasing to decreasing. You'll get a maximum. Local minimums happen when the derivative changes from negative to positive at a critical point. The absolute maximum, it could be at a critical point. It could be at a local maximum, but it could also be at an endpoint, and we'll talk about that on another day. An absolute minimum could be at a local minimum, or it could be at an endpoint. So that's what we're going to be using over the next few days. I hinted around at this already when we looked at horizontal tangents, but it really is amazing that you can find maximum and minimum values by hand without having to use your calculator. derivative equal to 0? At the maximum, so over here somewhere, negative 3-ish, I like that. It might be a little off, but it's all we were given this graph. And about 1 and about 2. And we may be a little off on those. It's just on what interval is f of x increasing? And when is f prime positive? Maybe, right? Yeah. Why? Okay. And so in what intervals are we decreasing? Wherever this happens at, right? We did say it happened at 1, so I'm going to stay consistent with what we already said it happened at. But you might be right. It could be a half or something. Does that make sense? And then from 2 to infinity.
Do we have to put the U in between?
You don't have to, but it is good mathematical. Okay, this is a test called the first derivative test. You don't have to write everything down. You'll kind of see what you want to find. The first derivative test is a test to see if critical points are maximums, minimums, or neither. We already said this on the summary, but this is the official what's called the first derivative test. Later, some people will accidentally in justification say that the first derivative test says something is increasing or decreasing, and it doesn't. First derivative test tells you if something is a maximum, minimum, or neither. So that's what it tests for. If you have a critical number c of a function s that's continuous on an open interval I containing c, the first derivative test states that if f is differentiable, why would it have to be differentiable? We have to have an f prime, except possibly at c. Or a critical point, it could be a sharp corner, right? So they're saying the only place that it can be not differentiable is at the critical point. Then f of c can be classified as follows. If f prime changes from negative to positive at c, so everyone watch, f prime, negative to positive, what are you going to get? A relative minimum, because you go from decreasing to increasing, so we'll get that bottom out point. Does that make sense? If f prime changes from positive to negative at c, then you get a maximum. If it doesn't change signs, then you get neither a maximum nor a minimum. So this is just officially the first derivative test on how you can test using the first derivative for maxes and mins. So the first derivative test is used to determine if the critical point is max, min, or neither. I don't really like the word fake. It's in the textbook I was using use the word fake, but it's either a maximum, minimum, or neither. Find all of the relative extrema on x cubed minus 3x plus 2. Well, I'm going to find the first derivative. What is the first derivative? I need to know when it equals 0, right? So set it equal to 0. Make it 3x squared.
3x squared.
Okay. You're right. 3x squared minus 2. Set that equal to 0. And if that equals 0. Good. 1 or negative 1. Everyone agree? So I'm going to remember in Algebra 2 when I made y'all do solving inequalities by sign charts. There's a reason I'm making you do it this way. I remember that. This is the reason. So I'm going to do a sign chart. You do need to know that AP will not grade a sign chart for justification. If they say that find the extrema justify your answer. You will have to take what's on the sign chart, put it in words, but the sign chart will help you find it. It just doesn't say justify, so we're just going to do it. I want to know if the first derivative is positive or negative, right? So I'm going to find out. I'm going to plug in a number less than -1 into the first derivative. So what's a number less than -1? -2. -2 squared is 4. 4 times 3 is 12 minus 3 is 9. That is definitely a positive number. I'm going to put a little plus there. Have you ever seen this before?
No.
In between -1 and 1? And 0 minus 3 is negative. And then from 1 to infinity, you pick 2. And I would get a positive. So remember, this is the first derivative, right? So what that means for my function, you don't have to draw this part, but that does mean for my function it is increasing, then decreasing, then increasing. For some of you, drawing that will help your brain figure out which ones are maximums and minimums. So you tell me which one is the relative maximum at -1. Which one's the relative minimum? 1. Everyone agree? Now it does say find the extrema, which is a what kind of value? The y value, right? So have I found y values yet? How do you find y values? The original equation, right? So plug the 1 and the -1 back into the original equation. So if I plug in 1 cubed is 1, 1 minus 3 is -2, -2 plus 2 is 0. Okay. Plug in the -1. If I just, or sorry, positive 1. I get 0 if I plug in positive 1.
Did you just say, well, okay, what was the relative?
Min. I can't tell absolute differences. We'll have to figure that out another day.
So you're saying it's saying to find the extrema. What would we have looked for if it said something else?
Well, it says find the extrema, which is y values. Find the maximums and the minimums, which are y values. If I plug in -1, I get -2. Right. So I have a maximum, right, of -2 at -1. And a minimum.
Teachers and students, to your attention please, a couple announcements concerning AAP CAP today. If you have Coach Jones, your CAP advisor, you need to report to the counselor's office today. Coach Jones' group, report to the counselor's office. Art Club is having a meeting in room A16. The list of students was on the announcements this morning. They do not have gold slips. And Ms. Honkola is absent today. She does have a sub, but she said she had given out 4 or 5 golden tickets. Those students need to stay in their normal CAP groups. Do not release them to her classroom. Thank you.
Let's try plugging in -1.
So we plug in -1 to the
To the original. The original. And you get 4 minus 1 is -1 plus 2. 1 minus 2
You're being nice and
5. 5.
That's good. I was confused, I got -2 there.
Wait. She's 5. That's not negative. It's 5. It says negative. Yeah. Which is possible. It is possible for a relative max to be smaller than a relative min, depending on where we are, but not on this. Okay, let's look at what this means. This looks like.
Can you explain how that works?
What?
How minimum can be bigger than maximum?
But say we,
like a relative.
yeah, a relative min, like if you had a little dip right there, that relative min could be bigger than that.
Oh, okay, so not
So,
the same, like,
Right, it could be. But it's not on this one. At -1, we have 5 at 1, we have 0. And this is a maximum, and that's a minimum. Look at how good of a sketch I can get of this cubic without a calculator from that. I mean, do you know how to sketch a cubic? By hand? By a calculator? Right? No, we couldn't have gotten that accuracy without a calculator. So it's pretty amazing that we can do that. Any questions about that one? Adele is going to get us an okay, and we've got lots of time on this. We have a lot more to talk about with it. Page 198, 2 through 20, 20 through 30 each is due on Friday. I'm not even going to hand it out yet today because there's too much we can't do yet. It will be due on Monday, and then that page 198 will also be due on Monday. The only one of these things you could do yet is the 20 through 30 even, and it's critical points and maxims and minimums. So you can start working on it. Nothing's due tomorrow. Tomorrow I will teach all day tomorrow, and then Friday you will have a work day on Friday. Any questions so far? How's today feel so far? Good. Even though you've never seen a science chart before.